What else you got for me? 11. Oh, we got a new kid here. Look at that, everybody. 2020, we got a new kid. Perfect. Here we go. 9. What else you got for me? Yeah, you're darn right. 21. And 20. Everybody all good? 5 properties of every parallelogram. All right, here we go. Rectangle. I'll do the first one. All those properties. That's, guys, don't forget about that. That is huge. That a rectangle is a parallelogram, so it has all the properties. Plus, we got some extras that only apply to a rectangle. Only apply to a rectangle, nothing else. 11. Oh, that's all right. Hey, you know, take your time there, new kid. And stretch out a little bit. Oh, there we go. All 4 right angles. Yep. There we go. Looks great. Oh, there we go. 11 again. Karma. No. All right, and then there was another one I had you guys write down, which was based off of the diagonals being congruent and bisecting each other. All right, diagonals being congruent and bisecting, meaning these 4 pieces are equal. And I just wrote that they weren't. Okay, those 4 segments are congruent, which means they form .21. What do they form here? Yep, diagonals form 4 isosceles triangles. Nice job. And that's important because what's across? You take one of the triangles. What's across from the congruent sides? Congruent. What's across from these 2 congruent sides? Congruent angles. Form 4 isosceles triangles. All right, this is a lot of fun. All right, rhombus now. Rhombus. Again, all the parallelogram properties. What else in the rhombus? 14. What else?
All sides of the
You're darn right. That's big time. All sides congruent in a rhombus. Not the angles, but the sides. Oh, 14 again. Let's keep going with your rhombus properties. Yeah, right triangles now. Right triangles in a rhombus. Those diagonals do a little bit more too. 8. Yep, they're angle bisectors. Nice job, kids. Any questions there? I think I got all the rhombus ones right. Yeah. Any questions there? Okay. Welcome back. We're going to go right into proofs with these now. Rectangle and rhombus. I'm going to go out of order, though. I hope you don't mind. We are actually going to start with, oh, maybe nothing. Welcome back, everybody. Yeah, look at that. 2020, first one of the year, huh? Why? I'll let you guys go ahead and graph this first. Hi, Violet. Right over there. Naomi, 23. Okay. Violet, new number, 24. Okay. 24, yep. Yep. All right. Some of us just finish up graphing. All right. What's our job here? Prove this is a what? Rectangle. You will notice it's on a graph, which means I am not expecting a statement's reasons from you here. What I am expecting is something organized, though. And it will have the one of the three, two of the three, or all three of the following when you put it on a graph. Distance, midpoint, or slope formulas. Anytime you put a figure on a graph and ask it to prove a parallelogram, rectangle, rhombus, that's what I'm asking for, is to use slope, midpoint, and distance to do this. All right, and it does not have to be in a statement's reasons form, but it does have to be organized. I'll show you what I want. All right, we need to prove it's a rectangle, so you guys don't have to flip back and forth. There are three main ways to prove a figure is a rectangle. Ready? And we're going to decide as a class what you want to do. Okay? And these are, just so you know, these are on the previous page up in the text box. All right, just so you guys don't have to flip back and forth. I'll just do them right now. Don't write these down because they're already written down for you. We could show it's got 4 right angles. Okay? Show right away it's got 4 right angles. Makes it a rectangle. If I can't do that, I'm going to need to show it is a parallelogram first. Parallelogram, then 1 right angle. Okay, that would make it into a rectangle. Or, final option, I could show it's a parallelogram. Then, somebody, what's so special about the diagonals of a rectangle? Diagonals of a rectangle. Congruent. Then diagonals congruent. Okay? When you're doing these proofs where you graph them, this is the great news I have for you today. You can do anything you want. There is no wrong way to do it. Because sometimes, you know, when you do a statement's reasons, are you always going to prove the triangles by side, angle, side? No, it's a specific method when you do a statement's reasons proof. When you do it on the graph, any option is available to you guys. Any option. And as a class right now, we're going to pick the option we want to do together. All right? Is there an easier way than others? Maybe. If some of you guys like a certain formula over another, it's up to you. But as a class right now, we have to decide on which method we're going to prove it a rectangle. All right, so think about in your head what you want to do. Do we just go right to 4 right angles, or do we show it's a parallelogram first? Then with some extras. It's up to you. Think about it. There's no wrong answer here. It's whatever you feel comfortable doing. Okay, and I know we're going to do it as a class right now one way, but homework tonight, test next week, you do it whatever you feel comfortable. Okay? All right, how many people just want to do 4 right angles and that's it? To show it's a rectangle. 4 right angles and we're done. Anybody? Oh, nobody? Okay. How many people want to show it's a parallelogram? Then we'll do a right angle with it. Okay, and then parallelogram with congruent diagonals. Okay, looks like we're doing it that way. That's fine. Again, do you see what I'm saying? You do not have to do it this way every single time. But what I'd like you to do by tomorrow is, if you're going to ask me to show it's a rectangle, this is how I'm going to do it every single time. It's not like, I'll do it this way. The wind's blowing east to west, so I'll do it this way right now. No. Figure out one of these 3 ways to do it by tomorrow and say, anytime I need to prove it's a rectangle, darn it, this is how I'm going to do it. All right, every single time. All right, you guys ready? Parallelogram with congruent diagonals. You got it. Step 1. You're always going to put steps in here. Make it organized. All right, well, how do you want to prove it a parallelogram? You guys want to do parallelogram with congruent diagonals? I'm totally okay with that. I just need to know from you guys, because there's a bunch of ways I could prove it's a parallelogram. Ready? I could do this. Everyone agrees I could do that? What formulas are you going to need for that? Okay. I could do this. Ooh, this one's going to be, what do you need to show lines parallel? Slope. Okay. I could do this. The special case. What formulas would I need here? Slope and distance. Ooh, this one's going to be a little, see if I can get anybody. Diagonals bisect. Anybody know what formula I would need there? Midpoint formula, yep. So this is another decision you got to make. How are we going to show it's a parallelogram? You like distances? You're going to do this way. You like slopes? You're going to do this way. If you're really a champion, you can do it this way. Or if you like midpoint, you can do it this way. It's your decision, though. When you do this on your own, it's your decision. We're going to do it all the same way right now because I want you to see what the setup looks like. But when time comes to you're doing it independently, you make the decision on your own. We're doing 4 distances. Anybody? 4 distances. Okay? 4 slopes. All right? 2 of each. Midpoint. Looks like we're going midpoint. All right. And again, this is what we're doing now, but you guys understand that you do not have to do midpoint every single time. You do it whatever you want. Okay? Here we go. Midpoint. So I got to find the midpoint of what 2 segments now? P, R, and QS. All right, here we go. So step 1, you show me the formulas. Distance, you show me distance. Slope, you show me slope. Midpoint, you show me midpoint. So midpoint of QS equals, ooh, we can remember the midpoint formula? We got to review that. Add your x's and divide by 2. Add your y's and divide by 2. All right, I'll do that with you. So everyone look at the coordinate of Q and S. What are the x coordinates in Q and S? That's what I was thinking. 4 and 3, so 4 plus 3 divided by 2. And what about the y coordinates? 8 plus 0 divided by 2. And you guys, hey, listen. You guys that wanted to do distance, you're showing me distances of the sides now. You guys that wanted to do parallel lines, you're showing me slopes right now. Jenna, go. Oh, good to see you. It's been great. So this comes out to be, what do we got? 3.5 comma 4? Okay. And now do it for, we did it for QS. Now I got to do it for PR. Show me the midpoint of PR. And let's cross our fingers that it comes out to be 3.54. You got to show me the numbers. You can't just plug 3.5 comma 4 and assume it's equal. All right, PR. So what are we adding up? 0 plus 7 divided by 2. I like how that's going to come out. And 2 plus 6 divided by 2. I like how that's coming out, huh? So that's going to be 3.5 comma. Ooh, look at that. Okay. So step 1, show me your formulas. Slope, midpoint, distance. Show me them. Step 2, what did you just learn from your formula? This came out to be 3.5 comma 4. So did this. What did we just learn then? It's not a parallelogram yet. We didn't learn that. All we said was, what about PR and QS? Diagonals bisect each other. So QS and PR bisect each other. That's what we just learned. QS and PR bisect each other. And you're going to have to give me a Y. How do I know they bisect each other? Use the work you just did. What did you just show in step 1? They have the same, because they have the same midpoint. They share the same midpoint, however you want to word it. You guys are keeping this ordered in steps. All right, what do you think I'm going to say in step 3 now? We just showed QS and PR bisect each other. So what's my next conclusion then? If they bisect each other, what's that figure? PQRS is a parallelogram. This is what you guys wanted to do because in our case anyway, because diagonals bisect each other. Everybody good? Again, ready? If you said congruent, these would all be what formula here in step 1? Distance, and then you would tell me PS is congruent to QR and PQ is congruent to RS because distances are equal, and then it's a parallelogram because opposite sides are congruent. It's the same setup. It's just whatever formula you're comfortable with. We're not done though, are we? Still got to make it into a rectangle. What did you guys want to do? A parallelogram with? What was your option there? What did we pick? A parallelogram with? Congruent diagonals. What formula am I going to need in step 4 now? If I want to show the diagonals are congruent, need the distance. Hey, this is what you guys picked. Personally, I would have just shown 4 right angles, but that's up to you guys. All right, so now we got to do distance of PR and QS. A little review of the distance, big square root, x2 minus x1 squared plus y2 minus y1 squared. Or Pythag, remember, Pythag's always an option. Make a right triangle where PR is the hypotenuse. Okay, so what are my x and my y's here? 4 minus 0, nope, 7 minus 0, 6 minus 2 for PR. 7 minus 0, 6 minus 2. So what am I getting? 49 and 16. How's that look? Good talk. 65. We getting the square root of 65 for PR? Yeah? Okay. Now you got to do it for QS, the other diagonal, and you can't just write QS equals square root of 65. You got to show me the numbers that got there. Okay, QS. 1, 2, 3, 4, 5, 6, 7, 8 and 1, huh? 8 squared plus 1 squared. Everyone all good? Step 5, what did you learn? Remember, formula, what did you learn? Conclusion. So formula, next step, what did we learn? You're not ready to say it's a rectangle yet. What did we learn about PR and QS? Okay, then write that please. PR congruent to QS because, how do you know? Same distances are equal, however you want to word that. And then you got your conclusion. Showed it was a parallelogram. It's got congruent diagonals. That makes it PQRSA. It's now a what? Rectangle. Okay, let's see if somebody's got a good conclusion here. Why? Remember, use the work that you already did. How do you know it's a rectangle now? 15. Why is this a rectangle? Okay, need more than that. Need more than that. It was a what first? Now, there we go, because it's a parallelogram with, now finish it, CC. There you go. Because we're going to learn more figures in this unit that have congruent diagonals, but they're not a rectangle. Okay, so I need that parallelogram part in there. Whew. Everyone good here? Again, when you're doing it on a graph, are we all good on you can do it any way you want? There is no wrong, well, there could be a wrong way, but there's no wrong choice anyway. Questions there? Okay, but, and I'm not going to do this right now because I need to get to the rhombus, but when you do a statement's reasons, most likely, you're not going to have your choice. It's only going to be this way or no way. All right, everyone see the difference between these. When you get to the graphing ones, you can do whatever way you feel comfortable. Everyone see that. But once you get to statements reasons, which we'll do for the rhombus right now, there's only one way and that's it. Okay, everybody good there? We all set? Okay, all good. All right, let's go to the rhombus now. Let's go to the rhombus. Do me a favor here, because it's one less thing I want you guys to remember. You can cross off reason 4. Where I've never seen a way done. All right, so I only want those 3 reasons for you guys to be focused on. Show it's a parallelogram and then show the diagonals bisect the angles. That makes it into a rhombus, but I've never seen it done that way. All right, so let's just talk about these 3 real quick before we go to statements reasons. How do you show it's a rhombus? Ready? First, reasons number 1, you got to show it's a what first? Parallelogram. Okay, we got that now. We got that. Show it's a parallelogram and then show it's got what in reason number 2, in reason number 1, excuse me. Parallelogram with what? Parallelogram with, you guys can just read it if you want, 2 congruent consecutive sides. Are we okay on what that means? Ready? Say it's a parallelogram. There's 2 consecutive sides. Makes it a rhombus. Parallelogram. It's a rhombus now. All good? Okay. Go to reason number 3 for me. Show it's a parallelogram with, okay, in this, if I had, show there's a right angle. Okay, show there's a right angle. Or, if I don't want to say it's a parallelogram at all, I can just show quadrilateral with all 4 sides congruent. Okay? All right, so those are the 3 main ways. Just like a rectangle, I could show it's a rhombus. All right, let's do this proof here because I want to show you guys when you do the statements and reasons, it's one way or nothing. So I'll give you guys a minute here, mark up your diagram. A lot going on. Okay. So first thing I look and I say, all right, can I get all 4 sides congruent right away to make this a rhombus? TE congruent to EU, congruent to UD, congruent to TD. Can I get all 4 sides congruent all at once? Anybody think we can? Whew. I don't know, guys. Looks like that might be tough, huh? I don't think we're going to do it, right? All right, so my other two options, if I can't prove four sides congruent, my other two options is I have to prove it at what first? Parallelogram. All right, so this is stuff we did before break. I don't expect you to know off the top of your head, but can you get this duet to be a parallelogram? Again, can you do this for me? Can you do this for me? Can you do this for me? Maybe one pair. I'm not going to do diagonals bisect because there's only one diagonal. Think you can get that for me? Can you? Okay, ready? Let's start somewhere. Can you get a pair of parallel or congruent sides for me? Mike, let's go. We got to start somewhere. TE and why? What are the alternate interior angles you're referring to? Okay, ready? Here's one. Here's two. You want to rephrase your parallel lines for me? I don't think they're T. Okay, everyone agree. TD and EU, parallel. Good start. TD, parallel to EU. Alternate interior angles congruent, imply parallel lines. Good start, good start. So either now I either get these sides congruent or these sides parallel, and I got a parallelogram. Anybody see another way maybe I can get either those sides congruent or the other sides parallel? We got a lot up there for you. Keep thinking here. I don't want to give it away. Can I get TE and DU parallel, or can I get TD and EU congruent? So I can do special case here. Anything? You guys are forgetting where you came from. What's up, Kevin? How? Yeah, but the lines aren't parallel, right? Good thought, though. Lines aren't parallel, so I can't say 4 and 3 are congruent. Hey, let's remember where we came from here. Let's say you want TD congruent to EU. You want a pair of segments congruent. What do I always have done first? If you want a pair of segments congruent, prove the triangles congruent. Yes? So can you get me these two triangles congruent? I don't know. What do you already have, guys? I got D congruent to E. I got a pair of angles. I got one congruent to 2. There's another pair. And anybody see anything else I could do on my own? Reflexive? Can I prove these two triangles congruent? Yeah? Don't forget where you came from. Come on. TU congruent to TU. Reflexive. The triangles are congruent. Triangle DUT. Congruent to triangle. If I go DUT, ETU. I already gave that away, but it's going to be, is that side in the middle or not? Be careful. You got to know what angles we're talking about. We're talking these two angles right here, 1 and D. Is that reflexive side in between 1 and D? Nope. So we're using angle, side. So I can say CPCTC, TD, and EU congruent. Now do I have a parallelogram? Duet is a parallelogram. Why? Remember, I don't want special case, right? What's the special case say? Here you go. Enlighten us. 5. One pair, yep. Of, hold on, can't be any pair of sides. They have to be what to each other? One pair of opposite sides. Keep going. Congruent and parallel implies a parallelogram. Yep. It's a lot of work. Welcome back, huh? Honors kids. Still need to make it into a what? A rhombus. Okay, ready? Look at the two choices we have. It's already a parallelogram, right? Well, we can show the diagonals are perpendicular. Why is that a problem? That's not happening. So we're going to have to try to show two consecutive sides congruent, right? And let me put up once again. This is what we started with, everybody. Can you get two consecutive sides congruent? It's not CPCTC. You can't do that. Can you look at what I have up there, guys? You can do it. You can do it. Look at the diagram. Why are two consecutive? Which two sides up here are going to be congruent and why here? What's up, Jacob? DT congruent to DU. And don't tell your classmates why, but that is correct. It's not CPCTC. They're in the same triangle. DT and DU. Tyler, I saw your paw raised over there. Why?
In a triangle, congruent sides form across congruent angles.
Guys, that's an isosceles triangle. Across from the congruent angles are congruent sides. Yep. Yep. And now I just made duet into a rhombus. A parallelogram with, what do we show? With consecutive sides congruent implies a rhombus. If we hold on, if we graphed it, you could do any of the three right here. Any of the three. Okay, if we graphed it. All right. But statements reasons, it's probably going to be one way, and that's the only way. Okay? Do not for a second give up on tonight's proofs. All right, they're not that bad. If you look through, go ahead, look through tonight's proofs, please. Most of them I give you, it's a rectangular rhombus, so you can use the properties. And then on number 3, there's only 3 proofs, correct? 4, excuse me. All right, on number 3, you guys pick the way. All right, I need to prove it's a parallelogram. You show me why it's a parallelogram on your own way, and then prove it's not a rhombus. Okay? All right, come with all the questions you have tomorrow and who you're going to vote for, obviously. All right? 1 week from today is the test. 3 weeks from Tuesday, midterm.